In this short video, I'm going to look at what's involved in running a simulation with the Evolution Sim simulator. So here I am on the simulator page, and we can see front and center a table of cells. Now this represents our environment in the simulation. On the right hand side we have a control panel with two tabs. There's a preset tab and there's a define tab. So if I have a quick look at the preset tab, it's simply a number of different patterns that can be used without making any defined patterns. So if I go to the define, if you actually want to set up your own pattern, then you can select the cells that you're after and set them to either be detrimental or possibly neutral, and if we want to change them back to positive, there's the positive switch. There is a entry box for mutation rate, and there is a entry box for cell penalty. So I'm not going to discuss those in further detail here, but it is discussed in our other videos. Now we always have to set a start point. If a start point is not set, then it will be randomly allocated upon the start of the simulation. So clear all simply clears the environment, and clear selection is if you have a lot of cells selected and you just simply want to get rid of that selection without going further. Now the control button down the bottom is basically to control the iterations. So iteration number has a default of 1, and once we have a pattern selected and have a start cell where we want it, we can select go, and that will start off our simulation. We can make that a whole lot faster by increasing the iteration number. But if we want to start again, we have reset all. We get a message box, and if we say OK to that, then any previous version will be selected. So we can see now that it's running through 20 iterations per cycle. That's a lot faster than, say, if we want to only do it one generation at a time, so we can see a bit more closely as to what's happening, then we can do that as well. Please look at our other videos for interpretation on simulation and how it represents evolution in practice. Thank you.